It's my pleasure to introduce Jeff. I met you probably, what, about 25 years ago at one of our potlucks, right?
Yeah, a long time ago.
Yeah. Came over to meet the farmers in the mountains, you know. We had to travel far in those days to meet organic growers.
We didn't have very good vehicles either.
Yeah, right. So he's been in it a long time. I've always admired his work. I think if you've all been to our website, is that probably true? You know that he has done a previous presentation here that's much more detailed about all that he does. This is going to focus simply on savvy tillage because we're kind of heavily focused on no-till. And Jeff still does some tillage, and when he talked about it last time I realized he's doing it really the right way if you're going to till. And so, honored to have him, and I'll let you take over from there.
Okay, well thank you, Patrick. So it's great to be here, and it's nice that it's a small group. It sounds like you're mostly on the gardening side of things, and a lot of what I'll be talking about is tractors and farming. So I'm going to try to, whenever I'm doing that, I'll try to back off and talk about the garden tools that we would use. Do you guys have tractors at your place? BC. Oh, the walk behind. Right, yeah, okay. So just a little bit about myself. I grew up in Illinois where the soils were so good you didn't have to do anything. And my father was interested in organic gardening and farming. He was a farmer, a horticulturist. And so I grew up with organic gardening magazine in the house, and sort of, we always had a compost pile and did that kind of stuff. So I got a farm in the early 70s, and over the years have made pretty much every stupid mistake you could possibly make. And this goes from tilling too much to not tilling enough to not putting lime on, and just all kinds of really dumb things. And so the reason that I feel compelled to come out and talk to people is just to help maybe soften that learning curve for everybody else. So yeah, we raise about 150,000 pounds of produce every year, and we do this with no irrigation. We don't lay plastic down, and we don't have hoop houses. The way we do it is we follow the principles of permanent agriculture that were established in the late 1800s. And yeah, and I've been doing it all my life, so I found that I've always had to make a living by growing stuff, so I don't have an independent income, so everything has to make money. And I've just found that the biodynamic method is the cheapest way to do this, because you can get all the stuff from your farm. You don't have to go buy anything. Yeah, so today we're going to talk about tillage. And the question of tillage causes a lot of confusion. So the proponents of tillage, to till or not to till, that is the question. Yeah. So the proponents of tillage are saying that it helps to aerate the soil, and that it helps to stop erosion by going along the contours, and helps with drainage. And then the people that are opponents of tillage say, well, it destroys microbes and is bad for your soil structure. So we're going to try to add to the confusion. I'm going to tell you that I believe that you should no-till until you have to till, and then till until you can no-till. Okay, everybody got that clear? Yeah, so things are only good and bad in certain contexts. And this is a great lesson in life, because, if it's, say you get a thunderstorm. Well, if it's been raining for 3 weeks, that's not a good thing. But if it's been dry for 3 weeks, it's a great thing. So we just can't make these generalizations. So is tillage good or bad? It can be bad and it can be good. Yeah. So we just don't want to throw the baby out with the bathwater, and when we say that we're not going to till. Yeah. So going along the contour and throwing up ridges is a really good idea to keep if you're on a hillside, because when the rain's going down the hill, it gets caught and stays and soaks into your ground. Having your soils deeply tilled is really valuable because the water soaks in when it rains. It doesn't just run off. And then by surface tillage, we can prevent that rain from evaporating. So tillage has a lot of great things, and it also adds air for these microbes. So it's really valuable. But the way a lot of people till is really destructive to the soil, and it wipes out the microbes, and it messes up the soil structure. So we're going to try to go into this over the next few hours in a little deeper. And so I do want you to ask me questions while we're talking, and just I really would like to help you all learn more about whatever it is you really want to learn about. Tillage is just one aspect of farming, of course. So drainage. Well, so one of the first considerations in any kind of horticulture endeavor is drainage. And so I studied these old-time farming books. I'm really interested in how people farmed back in the 1800s. And in a elementary textbook, they have this one experiment. You take a tin can and you poke holes in the bottom of it, and you put some soil in it, and you plant some seeds and you water it. And in another tin can, you don't poke the holes in it, and you plant seeds and you water it. And then you wait a few days, and the students would do this, and wait a few days and see what happens. Well, in the soil that doesn't have the holes in it, the soil stays waterlogged, and nothing will sprout. Only it'll sprout if there's good drainage. So a lot of our soils puddle up when it rains. You'll get a big rain. You have that trouble sometimes with the...
Last year I heard from Jeremy that he would stick the trowel in the ground to make a hole, and it filled with water. So I'd say we have that problem. Yeah. It was a very wet year.
It was a very wet year, but we can't grow anything without drainage. So where I grew up in Illinois, that was all a swamp. And so every bit of the farmland is drained with tiles 3 feet deep. They go about that deep, and then they have to go downhill to a drainage ditch that, to run this water off. And so, and this not only takes excess water off, these drainage ditches let air come back into the soil and come up from below. And so air is really important, and we're going to talk a lot about that. So other ways to do drainage would be swales and keyline plowing. You've had experience with this. And just ways to manipulate the water on our farm so that it's never too wet or too dry. Yeah. So a thorough digging and loosening of the soil is what a gardener would do. So this is a schematic of what we call double digging. So if you read old agricultural books like Thomas Jefferson's diary or George Washington or some of these people that were farming back in the 17 and early 1800s, the first thing they did was they moved the soil 3 feet off the ground, dug it 3 feet deep. They wouldn't consider trying to grow a garden unless they'd gotten that deep and loosened that soil up so that it drained out really well. Now, mind you, they didn't do that. They had slaves that did that, but that's how they farmed. I think Jefferson actually at Monticello went 6 feet down, that's that deep, and then laid brush and stuff underneath it so it would, have drainage, and then filled it back with the soil. And this is really important because it allows that air in there. So a lot of our soils have they might have good soil this deep, but then there's a real hard layer. And if that's not broken up, then the water can't go down below it, and the water that's down there below it can't come up. We want to have an interaction between the subsoil and the surface. Yeah. So what we're doing here is called double digging. The first bit of soil is taken off, and that might be 10 inches or a foot down. And then you find this, where I live, it's yellow subsoil. What is it? Yellow here or red or?
It varies on the farm. This stuff right here, we have a perched water table here, so it can be kind of grayish when you get down deep enough. It's anaerobic.
Uh-huh.
This is a bowl here.
Yeah.
This is
right.
Yeah. But we have wet weather springs all over the place in rainy years.
Yeah. Right. So what we do then is after we take the topsoil off, then I take a pick and a fork and loosen the subsoil another foot down. And we don't bring that subsoil up to the surface. We leave it down there. And at this point, I always like to add sand, lime, or gravel. And if like one time I was doing a school garden and we were double digging it, and we just got some gravel out of the driveway, because it's limestone. And we stole sand from the sandbox from the kids. And we got sand and gravel in there. And it's really important because those things are permanent. They don't rot. And they'll keep the soil loose. And then we go right next to it and just push this next layer of soil over what we have just picked and shoveled and forked up. So, and then we continue this process until the whole bed is done, and then you take the first soil and put into the last trench. Yeah, and this is called a double dug bed. And when you're done, it will be raised a little bit because of all the air that you've added. Yeah. So at first, there's not a lot of air in the soil. Now we poofed it up with all this digging, so we have a lot of air in the soil. And it was really dramatic at the school garden I went, because they had some pretty nice soil about this deep. But if you took the hoe handle and stuck it in, it went in that deep. So afterwards, I stuck the hoe handle in this deep, and then I kept pushing the hoe handle, and the hoe handle went down that deep. And I could just see the light bulbs go off in everybody when they went, oh, our plant roots can now go that deep. And the soil moisture, it can drain and it can soak up water. And so it just really, really helps to loosen up all that subsoil and get that loose. So I'm going to step from the garden into the farm, and we use a subsoiler. And this is a 2-foot-long shank that has a shoe on it. And we pull that through the fields, and that breaks up the soil mechanically. So besides just the drainage, the subsoiling and deep dilling has a lot of other advantages. The water now, when it rains, it's not going to want to run off. It's going to soak down into the soil. And we live in an area that gets 50 inches of rain. Last year we got 100 inches of rain. But we almost always suffer from a drought at one point or another. So conserving moisture is really important if you're growing without irrigation. And we grow without irrigation for a wide variety of reasons. One is I don't want to use plastic. Another would be I don't think the food tastes as good. I like the moisture in my food to come from the soil and the rain. Yeah. I think the subsoil moisture has minerals in it that come back up. And and it just, I don't want to spend my time watering. So we feel like that the deep tillage is really important, and particularly in these bottomlands, because you do have standing water. And if you have water, that means there's no air. And if it's no air, then the plant roots can't go in there, as we talked about earlier with the drainage. Yeah. So we have to have it opened up. Yeah. So I just said farmers use a subsoil. This is a picture of a subsoil. This is about 2 feet from here to here. And here I am starting the path, but it'll sink all the way up to there. And it goes in. If it doesn't go in the first path all the way down, I'll turn around and just go back the same path, and it'll go a little deeper. And so sometimes, when it's really heavy clay subsoil, you might have to take several passes to get down there. Oftentimes I'll go behind it with some lime and just pour it right in that trench. and then run the subsoiler through that again to work that lime down in there. So the subsoil is oftentimes very acidic in the East anyway. And by getting some lime down in there, it'll sweeten that subsoil up enough where then if some roots get down in there, they'll be able to live, because the roots can't live in the very acidic conditions of most of our subsoils. Yeah, so that's a subsoiler. So now we're going to talk about primary tillage. And we're going to distinguish between two types of tillage. One would be our primary tillage, and the other one I'm going to call secondary tillage. So the primary tillage is what we do to get the land ready to plant the crop. So it's everything that's done before we plant the crop. In ancient agriculture, it was like sticks, and eventually sticks with a piece of metal on it were how we tilled. And this was the way it was done for a long, long time. Yeah. And then they oftentimes had animals that would pull these sticks through the soil. And it was in the 17th century, I think, that Jethro Tull invented the moldboard plow. And this revolutionized farming and made it possible to grow a lot more food, and consequently we had a great increase in populations. Yeah. So it was Jethro Tull, not the band, but a guy who invented this moldboard plow. And so it's the addition of air that we're getting into the soil by these things. So a moldboard plow flips the soil, and it does it kind of like this. And when you bend a book, all the pages slide on each other like this. And that's what happens when the soil goes over. It slips, yeah. And that gets air in between those layers. And so I'm going to talk a minute about why is air so important for growing plants. Well, these are the elements that make up 95% of a plant. And they're carbon, oxygen, nitrogen, and hydrogen. And they're all found in the air. So that's why it's so important to have air. So I got really confused, and this is a picture of me being confused. I should be scratching my head like this. And I was confused because I'd been studying organic agriculture for many, many years. And I knew that this legumes, that's a field of crimson clover, I knew that they had the ability to get atmospheric nitrogen into the soil. Have you all heard about this? Through rhizobium bacteria that lives on the roots. And I kept thinking to myself, that doesn't make any sense. There's no air, the air's up here in the atmosphere, and it's not the leaves though, it's these bacterial roots things that are doing it. And then finally it dawned on me, it's the air in the soil is where they're getting their nitrogen. It's not the air in the atmosphere. And so this was a big light bulb that went off for me. And so then I realized again how important it was to get this air in the soil. And that's actually what this legume family does, is they bring air into the soil. It's not just the nitrogen fixing ability, which is great, but it's also they're bringing carbon and oxygen and nitrogen into the soils. So they do this by opening it up with a big taproot that goes down below this little level of topsoil and into the subsoil. Yeah. So the growth of legumes is really, really important. So, so nitrogen then takes this living quality on when it goes into the soil. Now, what does that mean? Well, the nitrogen is 78% of the atmosphere, but it's inert. It's in a form called N2. So nitrogen as an element is lacking 3 electrons in its outer shell. And so it has three, you could look at it as it has three extras too. So nitrogen triple bonds to itself. Nothing else really does it like nitrogen does. And it becomes this N2, is never by itself, and it's virtually impossible to break that free and be able to get nitrogen available. So you can have crops that are growing with all this nitrogen in the air and there's nitrogen deficiency. Nitrogen is actually the limiting element in almost all chemical reactions, including agriculture. Yeah, so nitrogen is really important. So learning about nitrogen, this element, is really cool. So the way that it takes on a living quality would be by the life in the soil. So the nitrogen in the soil is in the form of live things, like earthworms, or earthworm poop, or bugs, or fungi and bacteria. It's all things that are alive. And once they're growing, then they're breathing in nitrogen, incorporating proteins into their bodies, and then leaving them as decay or dead bodies. Yeah. And so that's how we get nitrogen into the soils. Yeah. Oxygen, too, takes on this living quality in the soil. And it's part of the breathing. And along with hydrogen, it's part of the water cycles. So oxygen is extremely important, and it's brought in through carbon dioxide in the atmosphere through photosynthesis. So all plant growth starts with the leaf. And so a plant doesn't really grow from a seed upward. The seed has in it stored carbohydrates, enough carbon, hydrogen, and oxygen, and usually nitrogen. It has enough of that in the seed itself as food from last year to swell up, send a radical down, and put two leaves out called cotyledons. These would be the first couple of leaves. That's all done from last year's energy. Then the sun hits those green little cotyledons, and then the plant's radical root is going down, starts putting off side shoots. And that's when the plant really starts growing with its own force from this year. So the sun, it hits those leaves, and there's carbon dioxide in the air that goes through and joins up with hydrogen, and in some plants nitrogen, and then it goes down a tube. And there's these tubes in the plants. There's a phloem and a xylem, and these are tubes through the plant. If you cut a plant, this way and look in there, you can see these little dots. And so it goes down the phloem. And so as it's going through the plant, it's learning about that plant. So you have these carbon, oxygen, and hydrogen combinations that are actually sugars. And they go down into the soil. Now, each plant species makes a different kind of sugar. They're not all the same. So when you have a sunflower, that's a unique sugar that comes out, and it goes in plant down the phloem all the way to the end of the root and squirts out at the end of the root as a root exudate. It exits the root. Then there's things in the soil, bacteria and fungi, that eat that sugar. And if it's in the composite family, like sunflower, it's going to be food that feeds microbes, bacteria and fungi, that like to eat the sugars from a sunflower. Now, if it's a corn plant, it's going to put different types of food out that's going to wake up the microbes, the dormant microbes, that love to eat corn root exudates. Is this making sense to y'all? Okay. So when I started studying soil microbiology, my teacher said, I can take soil. You send me some soil, and I can tell you what kind of plant's growing in that soil, by which bacteria and fungi were active through a laboratory analysis. She claimed she could tell the difference between a red delicious and a yellow delicious apple. I'm not sure if that's true. But each plant species then does put out these different things, and it wakes up these dormant soil microbes. So there's lots of microbes in a soil. There can be billions of different microbes in like a spoonful of soil. And so there's a whole lot of life down in there. And the way it works is that the bacteria and fungi colonize the roots of the plant. And so when you pull a plant up in your organic garden, it'll have dreadlocks. The roots will look like they're coated in dirt, sticking to them. That's a good thing. Yeah, if you pull it up in a chemical field, they'll be bare. There won't be any dirt adhering to them because there's no biological activity living off of those root exudates because they've killed it with all their chemicals. So the primary feeders, bacteria and fungi, then become food for organisms higher up in the food chain. And this would be protozoa. And so the protozoa eat the bacteria and the fungi, and then their poop or their dead bodies has amino acid nitrogen that then flows back up into the plant through the xylem tube and feeds the plant. And that's where plants get their food from. So it's this leaf, things going down into the soil, goes out into the soil, comes back up, and this is a daytime process. And the nitrogen and calcium and things are nighttime processes. Yeah, so nitrogen only works at night. That's why they call it nitrogen. And yeah, so other things that happen are hydrogen comes from the sun. Do you all know a little bit about hydrogen? Hydrogen is the smallest element. It's the first element on the periodic table. It's the smallest thing that we know. Hydrogen makes up 98% of the universe. It's the largest thing by far that we know. So hydrogen is very interesting. It's infinitesimally small and infinitely large at the same time. It's almost like religious, isn't it? So we have this hydrogen, and the hydrogen has intelligence from the sun. It comes through here, it comes out, and the hydrogen ion that's exuded at the tips of the roots, which have fungal connections that are going into the soil, that hydrogen ion gets swapped for another kind of cation. And this would be your calcium, magnesium, potassium, sodium, whatever the plant needs. So as the plant is growing, it sends signals through the hydrogen into the soil intelligence saying, oh, we need some potassium. And then the plant roots then go out into the soil. Fungal hyphae at the ends of those roots go in there and they find some wood ash that this farmer spread last winter that's got some potassium in it. And then the hydrogen ion is swapped for that potassium and brought back up into the plant. So this is how it works in a humus soil when you're farming organically. Now, if we're putting potassium sulfate or potassium chloride or something that's water soluble, then the plant roots that are sucking up water can't help but suck up the water soluble potassium. And then the plant will get potassium even though it hasn't asked for it. And when you're farming this way, you're going to have troubles. So we don't farm using human intelligence. We're trying to farm using nature's intelligence. So we don't want any water-soluble fertilizers. And this is particularly true of nitrogen, because the water solubility of nitrogen would be in the form of nitrate. It's extremely poisonous. And when the plants want nitrogen, I would rather they're asking for it rather than us putting on a water-soluble nitrogen. Because in that case, the plant's sucking that nitrate up when it's really just wanting a drink of water. So instead of getting a drink of water, it's getting a drink of mellow yellow. And it gets sick. Yeah, just like we would if we drank mellow yellow. Yeah, so the problem with nitrate, a couple of problems. One is that it locks up and chases away silicic acid. And silica is really important for plants, and we'll talk some more about that later. But silica is the coating around the tubes that go up and down the plant. It's the coating that's around the fungal hyphae. So it's like this big silica tube that goes up to the plant, through the plant, all the way into the soil, through the roots, and through the fungal hyphae, into the various places in the soil. And these silica is not water soluble. So it makes it so that through the sap pressure created by boron, that the silica has these tubes so that it's like a highway. And then you have the flow of the cations, calcium and potassium and stuff, can go up this without getting lost some other direction, and that's how they get up into the plant. So nitrate is hard on fungal hyphae and things like that. But another problem with nitrate is that if it comes up into the plant as a nitrate, then the plant has to use some of its sugar to convert the NO3 back to amino acid nitrogen, which is what the plant uses to grow. So consequently, the plant uses up sugar to process nitrate. Well, that's the reason that your kale in your garden tastes sweet, but the kale in the grocery store tastes bitter. It's the conversion of those sugars to nitrates when you're using these nitrate fertilizers. So your plants will be sweeter if you just use compost and cover crops and things like that, rather than if you put on nitrate fertilizers like ammonia or urea, or even fish emulsion or unprocessed manures, tankage, blood meal, cottonseed meal, things like that, feather meal. All those things have nitrate, and we don't want that. So we won't ever use a fertilizer like Harmony or anything that has any kind of water-soluble nitrate, because I don't want those salts in my food. It makes them taste bitter. And so, and you can accustom your tongue to these tastes. Do you all know what I'm talking about? You taste something that tastes sweet, and you taste a same thing, same plant, and it tastes bitter, kind of salty. That's because of the way it was grown. Yeah. You can throw organic certification out the window. We have it. Organic certification right here. Everybody's got it. Just learn to develop these tastes. That's why people say homegrown tomatoes taste better. They're sweeter. Yeah, that's because they're grown with, in an organic garden or composted. They're getting their nitrogen through this symbiotic relationship with the soil food web, rather than getting it poured on by chemicals. Yeah.